All right, so now we're going to look at horizontal stretches and compressions. And just like horizontal shifts involve a change to the input, right, an inside change, horizontal stretches and compressions involve a change to the input as well, but it's a multiplier this time, just like the vertical stretches and vertical stretches and compressions involve the multiplier. So do the horizontal stretches and compressions. And again, because we are working with an inside change, right? We're making a change to the input. Things are a little counterintuitive. So this can be a little bit challenging, but we'll take a look at this first example, and we'll look at hopefully it'll make sense. So what we have here, we have the graph of f of x, and we're asked to fill in these tables for f of 1/2 of x, f of 2x, f of negative 2x. All right, so what I'm going to do, I'm going to scroll down because we don't need to see, we need to see the graph though to see the points. So the first thing I'm going to do is just fill out this table for x versus f of x. So I'm going to take some points from the graph. And I can see that 0, 0 is on the graph, right? So I know when x is 0, f of x is 0. I have a point up here, 1, 2, right? That's a point on the graph. And then 2, 0 is another point. And then finally, I'm going to take this point here over at 4. I'm not going to worry about this one, 3, half, but we'll just go over to 4 and take that point. So when x is 4, f of x is 1. All right, so that's just the basic input and output for f of x. So that is the input and output for f of x. So we're going to look now at f of 1/2 x. All right, so now the input to f of x is 1/2 x. So I'm going to use the same inputs, 0, 1, 2, and 4, because those are the inputs I know outputs for, given the table I just created, right? So, but remember, the input is 1/2 x instead of x. So, but when the input is 0, I get 0. And when the input is 1, I get 2. And 0 and 1. Just the same. I'm just copying the table that I have for f of x. All right. All right. So, but now, since our input is 1/2 of x, so then we have to figure out, okay, what does x have to be in order for 1/2 of x to be these values? So in order for 1/2 of x to be 0, then x is also 0. If 1/2 of x is 1, all right, that means that x has to be 2, right? Because 1/2 of 2 is 1. In order for 1/2 of x to be 2, then x has to be 4. And for 1/2 of x to be 4, then x would have to be 8. All right. So now I have x values and the corresponding f of 1/2 of x. Okay. So I can take these x, y coordinates and plot them. So, all right. So I'm going to do that. And so 0, 0 is on the graph just like it was before. But now the next point is 2, 2. Right. So I'm here. Next point is 4, 0. So I'm here. And then 8, 1. All right. So you can see, if I connect those points up, you can see what that 1/2 x, right, taking 1/2 of the input, does to the graph. It takes twice as much x in order to get the same amount of output, right? Because we're taking x and taking 1/2 of it before we run it through the function, all right? So it's going to take twice as much x in order to achieve the same output, all right? A little counterintuitive that we're taking 1/2 of x and it stretches the function, all right? So this function is a horizontal stretch by a factor of 2, all right? So I'm going to write that down. Horizontal stretch by a factor of 2. So I'll just write it all out this time, by a factor of 2. That means we're multiplying by 2. All right, so that's this first function. This is f of 1/2 x. All right, so let's do a similar thing for these other functions. So I'm going to change colors, but still I want the same input and output values, right? I want the input to I want the input to f to be values that I know. So I'm just going to, but the input now is 2x, right? So we're going to look at f of 2x, but the inputs are going to be 0, 1, 2, and 4. And the outputs are going to be the same, 0, 2, 0, 1. Okay. But now we have to think about, okay, if the input to the function is 2x and I want the 2x to be 0, then what is x? So x has to be 0. If the input to the function is 1, right, and the input to the function is 2x and I want 2x to be 1, right, then what does x have to be? It has to be 1/2, right? If the input to the function is 2x and 2x is equal to 2, then x is 1. And if the input is 2x and I want 2x to be 4, then that has to be 2, right? Because 2 times 2 gives you 4. All right, so now I have a set of x values and f of 2x values that I can plot. All right, so I'm going to plot them in this lovely blue color. So I've got 0, 0 still on the graph, right, down here. And then now we've got x equals 1/2, comma 2, right? So that's on the graph. So we have the 1/2 and we have a 2. Gives an output of 2. And then we have 1, comma 0 is down here. And then we have 2, comma 1. It's up here. So now I'm going to connect those up. And you can see now this is the graph of f of 2x, right? So what happened there? Now we've compressed it. We've shrunk it in the x direction. So we've compressed it. So we call this a horizontal compression. Horizontal compression by a factor of 1/2. By a factor of 1/2. All right. So again, a little counterintuitive, but hopefully you can see why that is. All right, so the last one, we've got f of minus 2x. Okay, so let me change colors. And so again, I'm going to have the same inputs. All right, I want the same inputs, but my input now is minus 2x. All right, and those inputs will give the same outputs, 0, 2, 0, 1. So I'm just copying the x and f of x values from the original table. But now my input is negative 2x. So if the input is negative 2x and I want negative 2x to be 0, then x is 0. If negative 2x is 1, then x has to be negative 1/2, right? Right? I can just, if you can't do it in your head, just set up an equation negative 2x equals 1, and then just divide both sides by negative 2, and then you get x by itself. All right. So if I negative 2x, I want it to be 2, then this has to be negative 1. And if I want it to be 4, then I have to have a negative 2 for an x. All right. So now we have a bunch of x and f of x values, and we can just plot those points. So I'm just going to scroll down a little bit. So we have 0, 0 on the graph. We have 1/2, comma. Did I get that right? No. Yeah. Okay. We have 1/2, comma 2. All right. I should have probably put this somewhere else. I was thinking I had room here, but I think this needs to go somewhere else. I'm just going to get this out of the way for now. All right. Because I need that space, right? So I have negative 1/2, comma 2. And then I have negative 1, comma 0. And then I have negative 2, comma 1. All right. So you can see we have this reflection across the y-axis, which is what we'd expect when we take the negative of the input, but then it's also compressed by a factor of 1/2. So let me just kind of connect those up. All right, so let me use the eraser and clean this up. Oh, no, didn't want to do that. I was trying to erase that little end of the arrow. Okay, so, all right, you know that this goes with the blue graph, and then for the red graph, we'll write it down here. We have f of minus 2x, right? That is now it's reflected across the y-axis, reflected across the y-axis, right? And it's also compressed. So, and we have a horizontal compression. Horizontal compression by, I'm running out of room here, by a factor of 1/2. Okay. All right, so that's this one. And then this is that one. Okay, so you can see we get a little, it's a little counterintuitive, but it makes sense if you think it through. All right, so let's look at the general rule for horizontal stretches and compressions. So again, we have a change to the input, right? We're multiplying the input by some constant b, and feeding that into the function. And if b is greater than 1, then it's compressed by a factor of 1/b. If b is between 0 and 1, then it's stretched by a factor of 1/b. So a number between 0 and 1 is like 1/2 or 1/3. So we take 1/b. So if b is 1/3, then we get a horizontal stretch by a factor of 3. Okay, so that's how horizontal stretches and compressions work, and I will meet you in the next video to look at combining that with other transformations. So I'll meet you in the next video.